Okay, the introduction to this question is kind of more complicated than the question itself. So the closed line segment is shown below. The first 3 steps, the construction of the Cantor set are shown. Step 1 removes the middle third of this line segment between 0 and 1, leaving 2 closed line segments. Step 2 removes the middle third from the remaining segments. Step 3 removes the middle third of the 4 remaining segments, and so on and so on and so on. It goes on forever and ever and ever. So they want us to complete the table to show the length of the line segments removed. So obviously for step 1, and this is step 1, okay, this is not step 1 here, this is step 1, they remove the middle third, so they've removed 1/3, okay? Now what you've got here in the middle here is you've got 0 here to 1/3 here, okay, and they're removing the center of that. So what they're removing is 1/3 of a line that's of length 1/3. So they're removing 1/3 of 1/3, which is a 1/9. So that section in here, this missing section, is 1/9. In here, it's exactly the same. They're removing 1/9. So altogether, they're removing 2/9. Now, obviously, this is a sequence and series. So we're kind of looking for a little bit of a pattern here. So why don't we just look at the next section here. So this is a length of 1/9 here. They're going to remove the middle section. So if they were to remove 1/3 of 1/9, that would be 1/27. Okay, they obviously removed the same thing there, 1/27, 1/27, 1/27. So altogether they'll have removed 4 27ths. Now let's look at the pattern. What do I multiply by each time here? So 1/3 multiplied by what will give me 2/9, and then multiplied by what will give me 4 27ths. If you can't figure that out in your head, it looks like it could be a geometric sequence, so I'll check it out. 2/9 divided by 1/3. Find out what that is. Then check if that's the same as 4 27ths divided by 2/9. And in both situations, you get an answer of 2/3. So we can see there's a common ratio is being multiplied by 2/3 each time. So continue on that multiplication. So 2 4s is 8, 3 27ths is 81, 2 8s is 16, and then 243. So part 2 here, we got to find the total length of all the line segments removed in the initial line segment of length 1 unit after a finite number of steps, n. So they're saying after n steps. So the total removed, they removed 1/3, then a 2/9, then 4 27ths, then 8 over 81, then 16 over 83. So we're adding them all together. So it's a series. We've already established that it's got the same common ratio, so it's a geometric series. So we're looking for Sn in a geometric series. A is our first term, which is 1/3. We already know our common ratio is 2/3. And then the number of steps here, they've just said, is n. So we're going to fill in that to our Sn formula. So we fill A, or, and n into the formula, and then you'll see at the very end here, you'll have a 1/3 top and bottom will cancel, leaving you with 1 minus 2/3 all to the power of n. Find the total length removed from the initial line segment after an infinite number of steps. So it's a geometric sequence. They want an infinite number of steps. It's a geometric series that we're looking at. So it's S infinity formula. We have A, we have or. We just fill in and evaluate. So we just end up with 1/3 over 1/3, which is 1, which makes sense because if it goes on forever and ever, essentially you remove the entire line segment. Okay, so part B, complete the table to identify the end points labeled in the diagram. So give your answers fractions. So back to the original diagram. So look how the points are labeled. Here we've got an entire length of 1. Then it's chopped into thirds. So the first end point is 1/3, which will make, obviously, if I go another distance, the same distance again, this will be 2/3. Then this will be 3/3, which of course is 1. So A will be 2/3. Now, if we just look at this part here, it's 0 to 1/3. We chop that into thirds. 1/3 times 1/3 is 1/9. So each gap is 1/9. So this is 1/9. Here's 1/9. And we do go another 1/9. So it's obviously 2/9. This is obviously 3/9, which is the same as 1/3. So B here is 2/9. Now in step 2, the gaps, each gap is 1/9. So the gaps on the right hand side are 1/9 as well. So I've got 2/3. So I need to add on 1/9 here. So this will be 2/3 plus 1/9. So I calculate that, which will give me a point of 7/9 for C. And then of course I've got another gap of 1/9 as well. So this will be 7/9 plus 1/9 for D as well. Which will of course give me 8/9 for D. Okay, now we're moving down to the bottom section. So we can see that our gap here from 0 to 1 is a 27. So everything on this line, all the gaps are 27. So this is a 27, this is a 27, this is 27. So like this is 3 27ths, which we can see is a 9th. So either way, all the gaps here are 27th. So what we need to do is we have B already. B is 2 9ths. That corresponds to this point here. And we need to add on a 27th to get to E. So we do 2 9ths plus a 27th. And we get 7 over 27. So that is our point E. 7 over 27. So remember, all the gaps here now are 1/27th. So I've got point D here, which I know is 8 9ths. So if I go plus 1/27th, that'll bring me to F as well. So I need to do 8 9ths plus 1/27th equals 25 over 27. So just to clarify, you're given the gaps at the start of each question. So your gaps here will all be a third. In the second question, your gaps are all a 9th. In the third step here, your gaps are all 1/27th. Okay, so that's 25 over 27. You give a reason why 1/3 minus a 9th plus 1/27 minus 1/1 is a point on the counter set. The point on the counter set is each of these dots. So we can see our first dot, our first point, well, that's not our first point, but this point here is a point on the counter set. Underneath, if I look at the gaps, I know these gaps are a 9th. So if I go back 1/9, that'll bring me to B. So that'll bring me here to B. And then plus 1/27th. Well, I know all these gaps in step 3 are 27th. So if I go up here, that'll give me point E when I get to 1/27th. And you can see here there's a sequence underneath. First of all, it's going minus, plus, minus. And then underneath, you can see the sequence is 1/3. Multiply it by a third to get a 9th. Multiply it by a third to get a 27th. Multiply it by a third to 21. So what it seems to do is it seems to give you a point on the counter set every single time. Now, the accepted answer was very, very broad for this, but if I was justifying this, giving the reason, I would say 1/3 minus 1/9 gives me point B. Then I'd say 1/3 minus 1/9 plus 1 over 27 gives me point E. So I would say the sequence, or the series, sorry, because you're adding and subtracting and all that, series gives points on the set. That's really as best as you can do for an explanation here. The limit of the series, 1/3 minus 1/9 plus 1/27 is a point on the counter set. Find this point. But essentially what they're saying is the limit goes on for infinity, basically. So they want the S infinity of this particular sequence. So let's have a look at it. So we can see it goes 1/3 minus 1/9 plus 1/27. So it looks like it's geometric, but let's just double check it. So when I do minus 1/9 divided by 1/3, I can see I'll get negative 1/3. And then if I do 1 over 27 divided by minus a 9th, I get negative 1/3. So I can see my common ratio is negative 1/3. A is obviously a third, so I can just fill it into my S infinity formula, which is A over 1 minus R. So the S infinity is 3/4, so the point that we have is 3/4.